So one thing that no one brought to my attention, and actually my girlfriend who was watching the video on YouTube told me, why is there clicking all the time? I can't hear that here. So if you're watching this on Zoom, please tell me if you hear something like that. I was made aware of it last night, so I haven't been able to completely fix the problem yet. I think hopefully, if you can let me know right now on Zoom, if you guys are hearing a click, any clicking right now, I think the issue is this webcam I was using. Every time I auto adjust, it clicks. And I think it picks up the audio a little bit better, but when it adjusts for the video, it was making that clicking noise. So I've got switched to just my laptop. You shouldn't need to see me a whole lot, so I know the video quality is terrible right now, but at least you won't be getting that clicking every couple minutes, which is very, very annoying. So I don't know why you guys were here today. You should have said something because it was terrible. So from here on out, hopefully any issues like that, bring them to me. Like I said, I knew there's gonna be a couple bumps along the way this first week until we get things figured out. But I think I've got that settled now. So hopefully all of you, if I can get anyone to either speak up or in the chat, let me know if you are not hearing that clicking. Is that true? False?
True.
Okay, thank you. All right, so today what we're gonna do, and I also figured out why the screen was pausing last time as well. It's because I didn't click on the screen right. So first thing here on our Canvas page, we go to Files. So I don't think for you guys I should have to update this, but if I have any add drops during the week, I'll update the seating chart. So I'll update today, check the class roster again. And I'll do that on Friday as well. There shouldn't be any, if you're already in the class, it doesn't apply to you, but if you've added late, you may not show up in that class seating chart yet. But I'll continue to be checking the class roster throughout this week as people add and drop. I added a new folder, which is this in-class data. You kind of see there's two files in there right now, COVID, blah, blah, blank, and then complete. So I think even today we might start playing around with this a little bit. We'll start with that blank file, and hopefully by the end of class Friday, we will have done all the work so that what we've done with that blank file, it should look just like that completed file, right? So as you're working along with me, we're essentially going to be building this data set into having graphs and tables and some statistics that we can find like the completed, like correct way to do it in case like you were working along with it and messed up and you couldn't keep ahead, couldn't follow with me. You'll have that completed version either way, okay? And ignore this. I got a ticket yesterday, even though my car is registered, so that's annoying. So if I start kind of working with this file today, you can find it right here, okay? And if you're in class and didn't bring your laptop or something like that, just kind of write some notes along what I'm doing. It's not that big a deal. We will definitely not work through the entire thing today. We might just get a first kind of glimpse at working with some data in Excel. Okay. Like I said, even if the audio or anything is bad on Zoom, do not be afraid to let me know. Still trying to work everything out here. And I'm going to go through things relatively quick here initially. A lot of it shouldn't be. Let's see. Make sure we don't have anybody waiting before I get going into this. All right, we're good. And I'm just going to close out of this because I don't know why it's making noises here. So I'll go through the first stuff pretty quickly. A lot of it is, I think, really simple for you guys, especially being kind of in the honors section. I expect a little bit more out of you. So I just put some data sources here. Anytime I work with a data set, if you're ever interested, especially for those individual assignments coming up, if you're interested in where I got the data or where the data is from, I sometimes forget to tell you the source. I'll try to remember who that every time, but if I don't, by all means, ask me where it's from. Also, when I post these YouTube videos, I had a question. I'm not posting them up and taking them away before the next class. That was specific to the online quizzes that I'll post the first one after class today. Right? The YouTube videos will live up there and infamy probably, right? They'll be there as long as we have this course, okay? So I pulled this. I know not everyone likes sports data. I'll try not to use a ton of it, but I'll tell you why it doesn't really even matter in this context, right? we have this data set. It's the Chicago Cubs. They pulled some of their players, the position the player played on the team, and their salary. Why does this not matter if it's sports data? These columns, right, are what we're going to call the variables. And these rows we're going to call the observations, right? So here I have one observation for one player and their recorded position and salary, right? Each row is an observation. Oh, did I hear someone? Oh, okay. And each column is a variable, right? Well, if I don't think about this as a sports team, the variables of name, position, and salary could very well be John Smith, office administrator, making $35,000 a year, right? The variables are to be applied to a bunch of different companies. It doesn't have to just be a sports team, right? So I just pulled this because it's easy data to get, and I don't have a bunch of different companies' data. So we've got these three variables, right, recorded for every single one of these observations in our data set. Okay, as simple as that. Okay? You might see these called elements sometimes. I'll never use that term. I'll always call them observations. So we have different types of data sets, or sorry, I'm getting ahead of myself. We have different types of data. The first is qualitative. Basically, the way to think about this is qualitative variables are words. They're not numbers, right? That easy. We then have, if I had like a used car data set, an example would be the color of the car, right? Or maybe the make of the car, right? That's just a word. Quantitative is essentially numbers, right? Any variable that we record for an observation, any variable that has numbers to it, that's a quantitative variable, right? So the used car, you get the mileage, the year the car was made, anything that's a number that we could record for that observation. Right? So two types, qualitative, quantitative. I think it's pretty easy to distinguish the difference between the two. Quantitative numbers, qualitative words. Okay. So if we want to break these down even further, we have two types of qualitative variables we'll talk about and two types of quantitative variables. The first is a nominal variable. So if we have a qualitative variable, some words, and it's nominal, it's basically something we recorded that has no intrinsic value. If I say took everyone that's here today, I started to record all of you, each one of you is an observation, I record your hair color, that tells me nothing about you as a student, right? It has no intrinsic value. I can't rank you based off hair color or anything like that. Right? We could do gender, we could do the baseball positions. If we look at that first data set I showed you, the variable of position, right, was just a word, starting pitcher, first baseman. Not a number, it's just a word, right? So it's a qualitative variable. And it's nominal because that word has no intrinsic value. It doesn't tell me anything about, I can't rank individuals based on their hair color. I can't even really rank players based off their position. Right? So, well, maybe some of you have, put one of you have, but we can't. So we've got our nominal variable of position or name. Name's also nominal. I have name recorded, it's qualitative, but it doesn't tell me anything about that individual. It's an identifying characteristic, but I can't rank people based off of their name. Right? A probably more useful qualitative variable would be ordinal, right? Ordinal means I can kind of give some direction, all right, to the data. And so we think about there is some value to an ordinal variable because it allows us to like rank the observations, right? So think about something like this. At the end of every course, you're asked, does this teacher, what was it, instructor, are they an effective teacher, right? Do you agree, strongly agree, disagree, strongly disagree, or neutral? Well, those are words. So every time you fill that out, I have a recorded response. I can build a data set, but this variable that I'm recording takes on one of these 5 values, but these values aren't numbers, they're just words. But what I can do with this qualitative variable is I know if someone answered strongly agree, that they think that that teacher is better than someone who said strongly disagree, right? I can actually kind of rank like who thought the instructor was better and who thought they were worse. Right? I have some value to that response where I can rank the observation. Okay? So you can kind of imagine having an ordinal variable, even though it's still qualitative, we can do a little bit more with that. Right? Another example would be if I recorded someone's education level. If you tell me that you have some college, well, that could be 1 year, 2 years, 3 years of college. Some people take more time to get a high school degree than others. So it's not a number, right? It's just that I have a high school degree. I have some college. I have a college degree. They're just words. But with that recorded response, it's ordinal because I can say someone who has a college degree has a higher level of education than someone that has only a high school degree. So these are some examples of ordinal variables. Like I said, this is not like quiz you on definitions here, but just start to think about the types of data that we're going to be looking at. Another good example of an ordinal variable is if I took everyone's grade from a course and said, okay, what's their letter grade? It's not a number, right? If you go to the register, I can't just see that you got a 92.3. I just see that you got an A or an A minus, right? But with these letter grades, with this qualitative variable, I can rank students on who did better in the course. Now, within each one of those responses, if I just see an A, I don't know who had the higher A, but I know that someone who had an A did better than someone with a B plus. And I can still rank them. Got some directions and ordinal. That's what that ordinal word means. I can kind of rank these based off of the response I see for that variable. Okay. Any questions on this? I know I'm going through it quick, but it's not. Okay. We want to break down quantitative variables into two types. We've got discrete and continuous. So discrete variables, you can kind of think about these as, for the sake of this class, you can think of a discrete variable as basically integers, right? I could ask you how many kids are in a household. 0 could be a response. 1 could be a response. 2. Hopefully no one's saying like 1.5 kids, right? You shouldn't have half of a kid, okay? So we've got these gaps in between the responses that we can see. So we could see 1, we could see a 5, we can't see 7.3, right? Or we can't see anything kind of in between. Now, if we want to get real technical, right? If there's like a pure stats and an applied stats course, we could say there are variables out there for which maybe you could have 0, 0.5, 1, 1.52, right? It's not integers, but there would still be gaps. We'd still say that's a discrete variable. For the sake of this class, examples I'll use, I'll be very clear. Like we're just going to be using integers for discrete variables, and when we get to continuous variables, we'll talk about that in a second. That's where I can see things like 7.3591, right? That's a response I could see. Okay? So continuous variables, kind of the opposite of a discrete, right? It can be any number, right? It can be any number, doesn't just have to be integer. There's no gaps. And so when we look at the number line, oops, oh, my number line's not showing up. Well, you kind of imagine. I'll go back to this one. I could see 1, I could see 5, but for a continuous variable, I could see 7.3159, right? See any decimal, right? So some examples that we're probably working with, height, right? If I had a good measurement tool, I could measure height to whatever decimal I want, weight, measure it out to whatever decimal I want, and then something like income. Okay? So sometimes I get some people who, let's see, there's nothing in the chat. Okay. I'll get some people who kind of want to, I don't know, always want to prove the professor wrong or something like, well, isn't salary technically discrete? So why could I argue here that salaries could be considered discrete? It goes against what I said. I said, for us, we'll just use the integers for discrete variables, but why could you say that salary here is technically could be considered discrete? Think about what discrete means. There's gaps in between the values we can see. If I'm paying you with physical money, what's the first amount of money I could pay you with? 1 cent. What's the next thing? 2 cents. Can I pay you with 1.5? No, I'm limited at that second decimal. So if you wanted to argue with me theoretically, salary is discrete, you could be right, right? Because we do still have gaps. For the sake of this class, anything that we have that goes up to a second decimal, we'll kind of consider that a continuous variable, right? And really, theoretically, it's not going to be much different than a continuous variable. Okay? Now, I always like to go, sometimes I go on our sides here. Has anyone ever seen Office Space? Like a young Jen Aniston? So like this is a great thing, right? So a lot of times when someone comes at me about it's technically discrete, if you look at pay stubs, they're actually not limited to only being to the second decimal. You can get paid 0.33333 cents. So like the premise in that movie is they just like start chopping off everything past the second decimal and like storing it in another account. And they were doing it with transactions. So like think about stock market, there's so many transactions we make. If you did that, you could get millions of dollars very quickly. That's beside the point, but it's a great movie. I know it sounds nerdy, but it's like absolutely hilarious. Like they take a baseball bat to a printer while, you know, some rap music's playing. It's great. Anyways, so salary, we're going to treat it as continuous, 2 decimal points, right? So if we look back at that Cubs data set, we had the salary variable. I censored it off here just so it was easier to see. But if we look at the actual data, this went out to this, you know, cents here. Actually, some of these were 0.3333 repeated. So we have a nice continuous variable here in salary. Okay? And continuous and discrete variables are under what category? So we could break it down. So we started out qualitative, quantitative. Discrete and continuous are quantitative variables because they're numbers. Go back to nominal, ordinal. Those were qualitative because those are just words. All right. So this is kind of the types of variables that we'll be dealing with. The next thing is just the types of data sets we'll see. So I'll just put them all up here right now. We've got cross-sectional, time series, and panel data. Okay? The easiest way to think about this is cross-sectional is I have multiple different subjects I'm collecting data on at one point in time. And I'll show you examples up here in just a second of what these data sets would look like. Time series, I have one subject. So it might be like I only am looking at the United States, but I'm recording the variable over multiple points in time. So I might be recording the United States unemployment in 10 different years. Okay? But the cross-section would be like I have 20 different countries, and I collect their unemployment in 2019 or something like that. Okay? So it's a little bit different there. Cross-sectional, multiple subjects, one point in time. Time series, multiple subjects, sorry, one subject, multiple points in time. And if I want panel data, I'm basically smashing those two together. So I'll have multiple subjects. So maybe I have multiple countries, and I collect their unemployment rate at several different years. Right? So I get smashed cross-sectional and time series together. Any questions on that before we keep moving here? I don't see anything in the chat. Oops. So I'll show you some examples. So here we've got a nice cross-sectional data set. I've got several countries. I've got multiple variables that I'm collecting data on, but I've collected GDP per capita, education expenditures all in 2011, one point in time. So that's cross-sectional. I then have the United States. So now I have one subject collected their unemployment rate at multiple points in time. This is time series data. And then I've got this data set where I've got ISTEP scores, several different years for multiple subjects, right? Here's student 1, 3 years I collected their ISTEP data. Person number 2, 3 different years I collected their ISTEP scores, so on and so forth, right? So I've got multiple subjects here, multiple students, multiple points in time. Okay? In fact, I think you guys are not old enough yet. If you were in Indiana schools from 2009 to 2011, grades 5 through 8, I would have your ISTEP scores in this data set. Okay, so we've got multiple subjects, multiple points in time. This is a nice example of a panel data set. And usually these panel data sets are preferred. They give us a lot more power to be able to do things, right? Because we have multiple dimensions that we recorded information on. Okay? Any questions up to this point yet? This is really just kind of setting some stuff up before we get into some real meatier material today. Okay. Let's see, no chat. Okay. So one thing I mentioned a little bit last class when I gave the example of looking at the last 10 years of World Series winners is that why we take a small sample of 10 years, why don't we take every single possible year out there, right? So the difference between population and sample data is population data would be something like this. If I want to know the average income in the US, population data would be every income earner in the United States. How can I collect that information? Maybe something like a census or the income, maybe something like taxes and the IRS hounding you if you don't report your taxes or pay your taxes, right? But it's very difficult to do, right? We only do the census once every 10 years for a reason. Very expensive, it's very difficult, it's kind of just manpower to get all this information collected. So usually what we're stuck with is taking a small subset of the population, right? Or a small sample. Okay? This would be like if I wanted to know what the average income in the US is, maybe I randomly sample 1,000 people. I can find the average income from them. That gives me a pretty good idea of what the average income in the US will be. Right? It's not every person in the US, but it's a pretty good size sample or a subset of that population. Okay? So most of the data sets that we'll be working with are going to be sample data sets. Well, kind of like that ISTEP one, that's a perfect example. I had population data on ISTEP scores. So I had every Indiana student in those years in that data set. Right? That was a population data set for Indiana ISTEP scores. As far as, to my knowledge, the ISTEP isn't used in any other state, so it is every ISTEP score ever recorded, okay, in those years. So we'll usually be working with these samples. So that what we're going to do is then take some statistic from the sample, like I already mentioned, maybe the average, and make an inference about the population as a whole, right? We do this because it's just impossible, right, to get population data sometimes. Either it's very expensive, right? Maybe let's not use income. Let's say I want to know the average height in the U.S. I can't go around and record every single person's height. It's going to take me forever, be very expensive. And honestly, if I probably grabbed random 1,000 people, I'd be almost identical to what the national average would be. Okay? It's also impractical. Instead of height, let's say I wanted to record the weight. By the time I record everybody's weight in America to figure out maybe what the exact obesity rate is, by the time I collect that data, what's probably true about a lot of people's weights? Probably went up or down, right? So now I've got data that isn't even accurate anymore, right? So it's just not practical a lot of the time to get population data. So we rely on samples, right? So once we have that sample, we then make some statistical inference, right? We use the sample to make conclusions about the population as a whole. Like I said, you're taking notes. I wouldn't worry too much about this stuff right now. I mean, you can jot stuff down, but I'm not going to like throw a bunch of definitional questions at you. We're just kind of setting some terms up that I might be using. Right? The statistical inference is using the sample to make statements about the population as a whole. Descriptive statistics will be the statistics that we calculate from the sample and then use those to make statements about the population. Okay? All right. Just threw a lot at you there. Any questions before we kind of keep moving? We'll jump into some actual like computation and working with some data sets today. Make sure there's nothing on here in the chat. All right. So the first thing that we'll start with is, let's say I have a data set, real simple data set here. I think it's 9 people and the grade they got in the course. I want to come up with a frequency distribution to understand what the grade distribution looks like in this course. Right? So all of frequency just means the number of times something happens, right? So you can think of a count or the frequency, kind of those two terms are synonymous. Right? So what I would do is, I would take every possible response I could see. I made this a little bit more simple, no pluses and minuses. So A, B, C, D, or F, right? I then go through, I say, okay, what was the count or the frequency of A's in this class? So I go through by hand, 1, 2, I write that down. How many B's? 1, 2, 3, write that number down. So on and so forth, right? Once I do that for every possible response I could see for this variable, I now have my frequency distribution. If I look at those numbers right away, what's the most common grade in this class? Yeah, a B, right away. It jumps out at you, right? 3 is the highest. What's the least common? D and F, right? That's the lowest frequency, right? So right away, building this frequency distribution tells you something about the data. Now here, you're like, well, it's only 9 observations. I can kind of tell that looking at it. But what if I had every student at Ball State? Or I actually have a data set we'll use later in the semester. I have a data set of every student I've ever had in a business statistics course. Well, I don't want to go through by hand and count those up. And also, I can't just look at that and be like, oh man, it looks like I have a lot more B's than I do C's in this class. No, I need to get this frequency distribution to be able to start to understand that about this huge data set. Right? Now, I said I don't want to do this by hand, so probably by the end of today, maybe we'll get to, if not today, Friday for sure. How can I use things like Excel to take 1,000 students and get this frequency distribution pretty easily, right? And there's a way we can do that, and we'll work through that today and Friday. But for now, you can see how you would do it by hand. You kind of understand what the process is doing. Excel is just going to count it for you so you don't spend all day. If we then take that frequency distribution and go one step further, sometimes just looking at the numbers, it's good, but we want to kind of know what fraction of the students are getting A's or B's or C's. So all we do to get a relative frequency is take the frequency of every category and divide it by that total number of observations. Right? So if I had 5 students get A's out of 10, the relative frequency would be 5 over 10 or 0.5. It's that easy. Right? So relative frequency, another way to think about it is you're really just creating what we'll start calling a proportion. What proportion of students got A's? What proportion of students got B's? It's going to be a decimal, right? Because at the highest, what's the highest relative frequency I could see? 1. Yeah, someone's holding their finger up, right? Because if I had all A's in the class, divide that by the number of students in the class, anything divided by itself is 1, right? So I know that I'm going to have a decimal answer here for a relative frequency, another way I can think about this, it's just a proportion. That's all it is. Okay? Now, if I had a data set where I had the frequencies, so I went back to that Cubs roster data I had, and I got the frequency of every type of position on the team. How many pitchers were there, how many catchers, so on and so forth. Now that I have this frequency distribution, and I added up all those frequencies, well, remember, when I was creating these frequencies, I was supposed to be going through every observation in the data set. So I've counted every single observation. So if I add up those frequencies, I should have counted every observation once. So when I add them all up, I'll just get my total number of observations. Okay? If I go back to the other data set, 1, 2, 3, 4, 5, 6, 7, 8, 9. The original data started with 9 observations. When I look at my count or my frequency, and I add these up, 5, 6, 7, 8, 9, adds up to the total number of observations, right? That makes sense because to get those frequencies, I counted every observation once. Okay? So we have these frequencies. To get relative frequencies, all I have to do is divide each one of these by 25, total number of observations. I don't know why this is 13. I must have made a typo there. It should be 12, right? Yeah, I don't know what I was doing there. I'll fix this and repost the slides. Right, this should be 12. So I've got my relative frequencies for every single position, right? Now, obviously, the more possible responses I have, the more work I have to do, right? When I only had 5 letter grades, I could come up with a relative frequency for each one of those. I only had to do it 5 times. Here I had to do it, what, 9 times, 9 positions. So, but it's the same process every time, right? I just take the frequency, divide it by the total number of observations. So, right, they're all being divided by 25 here. Oops. Let's see if there's a chat. Okay. So I kind of probably should have set an animation to this because you already can see that if I'm adding up these relative frequencies, they add up to 1. Right? But they should always add up to 1. Why should they always add up to 1? So what's in the numerator for these relative frequencies? It's just the original frequencies. Right? Well, if I add the frequencies up, I said that's how I get my total number of observations. So I know the numerators here will add up to 25. I'm dividing everything by the same number, which is 25. So when I add all those up, 25 over 25 will be 1. And the numerators will always add up to the total number of observations. And to create the relative frequencies, I should always be dividing by the total number of observations. So especially once we get to Excel, if you're ever calculating relative frequencies and they don't add up to 1, you messed up, right? You made a mistake somewhere. You got to go back and figure out where it was, okay? Any questions on that? So those frequencies, right, when we add those up, it gives us the total number of observations. If we add up the relative frequencies, it'll always add up to 1 because it's all of the data, right? If I instead want to create percent frequencies, because a lot of the times we don't want to display things as proportions, people just see percentages. I think they think about it a little bit easier. How would I turn those relative frequencies into percentages? Well, all I have to do is, if I had 5 out of 10, what percent is that? 50%. Well, the relative frequency 5 out of 10 is 0.5. So what did you do there? You moved the decimal point 2 places, or you simply multiplied it by 100, right? So notice here, this is how we found the relative frequency. So we took that relative frequency and simply multiplied it by 100. Now, it seems kind of trivial, but one thing we'll do a lot in this class is we'll take the decimal form of something like the proportion, which will be between 0 and 1. Right? We said those relative frequencies, we can think about them as proportions. They'll always be between 0 and 1. And we can quickly turn them into percentages by moving the decimal 2 places. Right? A proportion of 0.25 is 25%. Right? Or working in the other direction, instead of multiplying by 100, if I wanted to go from a percentage frequency to a relative frequency, I would be not multiplying by 100, but dividing, right? So I've got 30%, that's a relative frequency or proportion of 0.3. Right? So we'll be kind of moving back and forth in between proportions and percentages a lot this semester. And here's kind of the first time we see it, okay? So that first online quiz that I'll post today, after class, or not after this class, but I teach right after this, so it'll be after the next one. I'll get that posted up there on Canvas. it'll have a question that probably looks something similar to this or something along the lines of what we're going to be talking about right now. So these sample questions, anytime you see in the slides sample question, that's a good indicator that, ooh, this might be really useful for when I go on to take that quiz later, okay? So here I've got 8 years of data, different causes of death, and really, I'm not showing you the original data here. The original data was like each person's death was one observation. So what I did was I went through all those deaths and got the frequency of deaths that were from heart disease, the frequency of deaths from malignant neoplasms, which is essentially the cancer, right? So now that I have all these frequencies, how do I turn them into a percent frequency? So what would I do here? What's the process? Yeah. Exactly, right? If I'm looking for the percent frequency of malignant neoplasms, I take the frequency of that, divide it by the total number of observations, right? Which is, this total came from adding up all the frequencies. Then once I've done that, I have the relative frequency. So if I want a percentage, last thing I had to do was multiply it by 100, okay? So here, I might then show you, like on the online quiz, maybe there's potential answers A through D, right? If I look at these, and this is like a course-long discussion I'll have right now. Don't ever get married to like your calculator or like get really focused on the computation. Obviously, statistics, excuse me, we'll have some computation to do at some point, but take a step back and think about what statistic you're actually calculating. I want a percent frequency here, and if I just take a quick look at these numbers, and I will round very irresponsibly right now. 4 million and 16 million, right? I mean, I'm rounding like crazy here. But 4 out of 16 million, 4 million out of 16 million is about what percent? Yeah, that's about 25%, right? Kind of easy to think about that division. So I think, okay, I rounded a lot, so it's not going to be exactly 25%, but it should be somewhere around there. So if I look at these answers, B and C don't make any sense here, right? Even D seems a little high, but I rounded a lot, so I don't know, maybe, right? But it prevents me from making really easy, stupid mistakes, right? If I just take a step back and think about what I'm actually trying to calculate, okay? So one thing, if you just divided 4.4 by 16.6 million, you would get about 0.27. But what did you forget to do? Well, I'm looking for a percentage. I have to multiply it by 100, right? So maybe I'm just entering things in my calculator. Oh, 0.27, that's got to be the answer. Well, no, take a step back and think about what you're looking for. Okay? All right, I'm going to make sure there's no questions in the chat here. All right. So I could do this for every single type of death, right? I could just go through same process for every single type. I mentioned the relative frequency should add up to 1, but what should the percent frequency always add up to? 100, right? Once I have the percent frequency for every type of death, well, I've recorded every single death and every single type, so that should add up to 100%. You almost think about if I want to do a pie chart here, well, once I draw on the slice, right, for every single one of these different possible causes of death, I'll have the entire pie, or the entire circle. You guys have all heard about pie charts before, right? Hopefully. You guys, it's like 7th grade science, right? So anyways, once we have these relative, these percent frequencies, we can create bar charts, we can create pie charts to visually display this information. Because yeah, it's great. If I look at the percent frequencies here, I can see, oh yeah, we really should be concerned about heart disease and cancer in this country, right? It's killing way more than half the people. But I can also show that really easy, right, visually with this pie chart or this, pie chart or this bar chart, right? So if I took this data, these percent frequencies, and I created a bar graph, it would look something like this, right? And so how did I go from, my frequencies to this bar graph? So here we're going to try something. That we'll be using throughout this semester. And a lot of the work that I would usually on board, I'm going to be using this overhead cam. What that means is I'm probably going to be doing a lot less switching between the board and slides because there's a little bit of a kind of hiccup in this and that it takes a hot second for it to switch over and switch back. So let's see, hopefully, those of you on Zoom, let me know if this is easy enough to read. Those of you in person, just let me know as well. All right, so I have overhead marker. I'm going to try to get some better markers for the future. Let's see which one of these shows up a little better. So if we had something like this, that shows up okay, yeah? But the pen doesn't really. So we'll go with a marker today. We're not doing a whole lot with this. I just want to try to make sure I could get it to switch over and to show up on Zoom. So those of you on Zoom right now, I also do want to double check. You guys are seeing, okay, so it works. You guys are seeing the overhead cam right now, right? Can I get one more confirmation? Awesome.
Yes, sir.
Perfect. So all I'm doing with a bar chart is really just, why is this backwards too? It should be not showing up. Oh no, it's showing up there. Okay. So all I would do is take my different causes of death. So heart disease, malignant neoplasms. I'm shorthanding here. I probably write these out when I have a finer marker. And all I'm doing is saying, okay, here's my frequency up here on the y-axis. How many people were killed by heart disease? About 5.5 million. That's where the top of my bar goes, and I'm drawing a bar there, right? How many people died from malignant neoplasms? I think it was about 4.4. Draw the top of my bar there, draw it down, right? I just go through and do this for every single possible cause of death, right? Now, I'm not gonna have you guys do like, create bar charts by hand, but that's the idea, right? I'm just showing you kind of the general idea if we went back to 100 years, right? So instead, we're gonna use things like Excel, right, to kind of create these for us after we've created these relative frequencies in Excel. So I'll show you, actually, let's try this. So now, oh, but you guys won't see it. That's too bad. So now on Zoom, you guys should be seeing the slides again, and then we're having to wait a little bit in class until they pop back up here. Maybe. No, it's not like that. Let's go to video. I'll go to camera. I'll go to share screen again. Now it should be all right. No? Now it should be okay here in class. All right. So we've got this bar chart that we kind of just talked about how we would build it. Now we're seeing it in class again. So we've got frequencies, the number of deaths up here, and we've got every type of disease. Now, obviously, the catch-all category of other is very high, but you know, that's every other possible cause of death, right? It's going to be like that. But it gives us a nice visual that, yeah, these are the two types of deaths we should be the most concerned with. They're killing the most people. Right? Now, if I instead use these percent frequencies, what's going to happen to that graph, that bar chart? It's actually not going to look any different. So if instead I put relative frequency here, I actually use the percent frequency. If we use the percent frequencies here instead of the actual frequencies, notice, other than maybe the kind of how big it is on the slide, nothing changed. So why didn't anything change? Well, I was dividing everything by the same number, the total number of observations, and then to get the percentage, I multiplied everything by the same number, 100. So think about it this way. 1 is half of 2, right? If I multiply both those by 100, 100 is also half of 200, right? So when I go to graph these, the relative size of the categories won't change. So it doesn't matter if I use the frequencies, the relative frequencies, or the percent frequencies, all the bar charts will look the same. They'll just have a different y-axis. So it's really up to you. If you want your captive audience to see the percentages, you can do that. If you want them to just see the raw numbers, you can do that. Okay. We can do a pie chart. Once again, I think most of you probably know the idea of a pie chart. I'll show you how to do this in Excel. It's pretty easy as well. So we'll talk about this in a second. So where are we at on time? Okay. I'll actually go over this right now then. So any questions on that before we keep moving here? So there's no questions in the chat, hopefully. All right. We're good? You sure? Okay. I like to see nodding heads. So if instead of qualitative variables, because right there we were dealing with not numbers, right? We were dealing with the type of death, which is a word, that we converted into a frequency and a relative frequency variable, which was numerical, right? But with the original data set, was the cause of death, right? So what if we start out with the original data set, which is, let's say income, right? Let's say I want to create a frequency distribution for income, and I go about it the exact same way I did as a qualitative variable. So what would I first have to do? Count up the number of people who made $0. Then I would have to do what? Count up the number of people who made 1 cent, and then 2 cents, 3 cents, right? Because I have to go through every possible response for that variable. That's insane, right? I can't do that. I'd have like a bar chart the length of the university, right? So what can I do? I'm going to actually force the data to almost be in these different bins or classes, right? So instead of counting the number of people who made 0, 1 cent, 2 cents, I'm going to say, how many people made between 0 and $10,000? Count up that, how many were in that category. How many people made between 10 and 20,000? Get that frequency. So I'll kind of create these bins or classes so I'll have fewer of them, right? And I probably couldn't even do it by 10,000 because I'd still have way too many categories. I might have to do something like 0 to 100, 100 to 200, 200 to 300, 300 and above, right? So a lot of times in these bins, notice there, I'll make them the same length, but then that last category, depending on the data, I might have to make a catch-all, right? Because if I was going to go by 100,000, well, I still have way too many categories because Jeff Bezos is making insane money, right? So I need to kind of make one of these catch-all categories on the end, okay? A lot of the times we can do it on the other end as well, right? Potentially, let's say I was going to do, what would be a good example here? Let's say I wanted to do the number of babies born within certain weeks, right? So like, what would it be like? 36 weeks, 37, 38, I don't know, the different kind of number of weeks. Well, I have to do a catch-all category on the other end, which is like catching all the premature births, right? So anything below 30, right? So it doesn't matter if it's the first or the last, I might have to create one of these catch-all categories depending on the data that we're looking at, right? But once I've got these bins and I've got my frequencies, everything's just like it was before. I've now got the number of people making between 0 and 100,000, 100 and 200. When I have those frequencies, I can turn them into relative frequencies, turn them into percent frequencies, and create my bar graph and my pie chart, right? So once I create my bins or classes, everything's the same as what we just talked about with qualitative frequency distribution. So when we come up with these bins or classes, right, we're still getting every single observation recorded. So once I have the frequencies of those bins, the frequencies should still add up to what? Once I have my frequency distribution, the frequency should always add up to the number of observations I had in the original data set. Because I've counted every single person once. Every single person who had income is in one of those bins now. So now those frequencies for those bins should add up to the total number of observations in the original data set, okay? So once we do this, once we have these frequencies and we put them into a bar graph, what we'll call this is a histogram. And that kind of identifies that, well, look, this data didn't start out as only 5 possible responses. I just made 5 bins, right? It's the same thing as a bar chart. It's the exact same thing. It's just that name refers to that the original data that was used to make that frequency distribution and that bar chart started out as continuous, right? Or potentially discrete, but more often than not, we run into the issue with continuous variables, okay? So kind of a rule of thumb, and there's no set rule on this, and I'll tell you in a homework or something what the actual number of bins or classes should be. Once again, bins and classes, those two words are just kind of synonymous. Usually between 5 and 20. Anything below 5 is not interesting, right? If I just if I said how many people make between 0 and 200,000, how many people make above 200? Well, now I just got 2 bars. That doesn't tell me a lot about the data. So I want probably at least 5, and probably no more than 20. You know, I get to more than 20, I've just got a really long bar chart. But you know, depending on what you're trying to convey and how much room you have, maybe you go a little above that. It's no hard and fast rule. How we come up with this bin length is we'll usually take the minimum value and subtract that from the maximum value in that original data set. So for the income example, I would take however much money Jeff Bezos is making, and I would subtract that, probably subtract 0 from that, right? Well, this is once again, this is like a good rule of thumb how to create your bin length, but it might not always work, because with the income one, Jeff Bezos' income minus 0 is going to give me way too large of bin lengths, right? So it's really up to you to use some common sense sometimes, right? But with data sets where this will work, this is the approach that we would do, right? I think in the one that we do in Excel, I'll actually show you this. We'll calculate the bin length, and then I'll make a little bit of an adjustment to kind of show you, yeah, this is a good place to start, and then use a little bit of common sense about what you should do there. But in the homework or something, I'll tell you the bin length, unless the question is specifically, what should the kind of starting bin length, or what would the best start for your bin length be, right? And you would use this equation. But in practice, we use a little bit of common sense, but this is kind of our starting point. So what we want to make sure, though, if we don't follow this bin length exactly, we have to make sure that our bins are the following. We have to make sure that every bin is mutually exclusive. So I was a little sloppy with my language earlier. I wanted to do the income one. What's the problem if I count the number of people who made between 0 and 100,000, and then count the number of people who made between 100 and 200,000? If you make exactly 100,000, you're getting counted twice. Well, that's bad because the frequencies then they would end up the total number of observations. So we have to make sure that these bins are mutually exclusive, which means I can only be recorded in one of the bins, right? So what I would have to do is say, how many people made between 0 and less than 100,000? And then the next one would be, how many people made 100,000 or more, but below 200? And then kind of continue with that. And when we get to the Excel, we'll walk through that as well. We have to make sure they're exhaustive, so that if we do kind of censor the data and stop at 1 million, we have to create a catch-all category to catch every single observation. Our bins should be recording every single observation. That's what it means exhaustive, that every single observation will be recorded in at least one of these data options. And then we want to try to keep them the same length unless we do one of these catch-all categories. So what I wouldn't want to do is, how many people make between 0 and 50,000? How many people make between 50,000 and 500,000? I don't want to start changing the bin lengths there, okay? Unless I do the catch-all. So usually I use clickers. I don't think we're going to get this far. We could calculate the bin length, but I think we're getting kind of short here. We've got a couple minutes left. So what I want to do is actually, we'll pick up here kind of next class. We'll kind of revisit how we find optimal bin lengths, but then we're going to do a bunch of Excel work. So I just want to kind of show you what this data set will look like that we'll start with on Friday. So I've got this raw data worksheet here. Ignore this, we're not going to use this. I have some state level data. So I've got the total number of, what is it, COVID deaths, total deaths, and pneumonia deaths. So right away, right there, because I'll start to, as we first get into Excel, try to point out all these things that I forget that I know that not everyone else necessarily knows. I think you're supposed to learn it in one of your ICM courses, but I've been routinely told that that doesn't happen. So what I just did there, if I can't see, notice if it's too small, the numbers won't show up, or like I just double click up here once it turns to this like black thing, little black arrows, and it automatically fits so I can see what the name of the variable is. I can see all the numbers, and I just did that for each one of these columns just to make it a little bit easier to read. I'll also, if I ever forget, please remind me when I start to do work in Excel to increase the view so it's a little bit easier for you guys to see. I will also routinely sometimes forget to do that. So yell at me on Zoom, especially if you yell. It sounds like God's talking to me through the ceiling, so I'll definitely do whatever you say. So we'll start playing on this data. It's kind of interesting. We've got COVID deaths. We've got the total number of deaths in these states from February to the end of July. And then we also have pneumonia deaths, which a little bit of a sneak peek. Kind of notice these COVID deaths and these pneumonia deaths are actually fairly similar across these states. So we'll start to see some interesting stuff kind of come out of this data. I'll probably be a slave to COVID data this semester just because it's very relevant. It's kind of interesting, and the CDC is putting it out there, so we'll get to play around with it a lot. But anytime we're going through things, if you ever have something like, hey, do you have any data on this? It'd be kind of interesting to see. Like, I'm open to ideas. Like, a lot of this is really just me showing you how to do something, and it doesn't matter what data set we start out with. So I've got things I think are interesting, but that doesn't always necessarily mean you guys think that's interesting. So if I ever start going through something like, all right, enough with like the sports data or enough with the COVID data, can we do something else? you know, feel free to come and give me ideas. Okay. All right, so we're gonna end there. Get registered for that first Connect assignment. We haven't really covered a ton of material to like work too far into it, but you can probably start to answer the first few questions. But get registered for that. That individual assignment is up there on Canvas as well. Email me your ideas. I can start to already. I've sent out a couple data sets, and I'm going to be working on a couple later this afternoon that people email me about. So I can get you that data real quick. And you can start getting that first individual assignment, which is pretty easy, kind of out of the way. Okay. All right. I will see you guys Friday, or talk to you on Zoom Friday. And for those of you on Zoom, I'll always leave Zoom up as people are kind of leaving, because I know people like to ask last minute